Episode 10, titled Manage the Full Asset Inventory and Lifecycle, we tie strong security to a deceptively simple truth. You can only defend what you can name, locate, and describe accurately. A live map of assets is more than an administrative spreadsheet. It is the backbone that lets patching, monitoring, access control, and incident response land where they should and prove that they did. When the inventory is trustworthy, you reduce blind spots, shorten investigations, and avoid the ritual of discovering critical systems for the first time during an outage. Our aim is to turn inventory from a periodic scramble into a continuously updated picture that guides decisions every single week. Start by defining the scope of asset broadly enough to reflect how modern environments actually work. Hardware is obvious: servers, laptops, network gear, and specialized appliances. But software, datasets, cloud resources, and even identities belong on the roster because each carries risk and requires lifecycle care. For every asset, assign an owner who can be named in a sentence and a criticality that states the blast radius if it fails or is compromised. A production database differs from a developer's test container. A privileged service identity differs from a kiosk account. A regulated dataset differs from public marketing content. Ownership and criticality keep the list from becoming a museum catalog and turn it into a working tool. Tagging and classification transform a list of things into policy-aware objects that drive handling, monitoring, and retention. Datasets carry labels for sensitivity and regulatory scope, which determine encryption requirements, access reviews, and retention limits. Systems inherit tags for environment, owner team, application, and criticality, which guide alert routing, maintenance windows, and recovery priority. Software receives categories for license type and support status, which influence renewal and end-of-life planning. The discipline here is consistency. Use controlled vocabularies, enforce tags in pipelines, and validate them with periodic sampling so tools and humans read the same meaning. When tags are reliable, controls can be both automated and explainable. The asset lifecycle is a story with distinct, observable chapters: request, procurement, deployment, operation, and support. A request captures who needs what and why, ties to funding, and names the owner. Procurement matches approved vendors and models. Deployment attaches configuration baselines, ownership records, and monitoring hooks. Operation maintains patches, backups, access reviews, and performance. Support handles incidents and changes with traceable tickets. Each chapter writes artifacts to the same place where the asset record lives, so anyone can read the file and see what happened, when, and who decided. That narrative is not bureaucracy. It is the evidence that allows teams to move quickly without losing memory. Maintenance and patch windows should be coordinated with business impact and designed for safety, not speed theater. Each system class has a standard window, chosen with the owner, that balances service-level promises with the need to keep software and firmware current. A change enters with a clear plan, a tested rollback, and a pre-change snapshot so reversals do not become improvisations. If monitoring shows trouble after deployment, the team executes the rollback decisively and logs the timeline, effects, and recovery state. This rhythm turns updates from nerve-wracking events into routine hygiene and keeps availability and integrity aligned rather than at odds. License management and version control for software often hide in the margins until they burn budget or risk. Track entitlements, seats, expirations, and usage against real installations so you can right-size renewals rather than guess. Link versions to support status and end-of-life milestones, and let those milestones trigger backlog items for upgrade planning well before security patches dry up. For internally built software, tie versions to commit identifiers and release notes so operations can explain what changed and why, and auditors can follow the chain without a tour. The benefit is control of both cost and risk. No surprise lapses, no unsupported versions silently running in production. Cloud specifics deserve their own attention because drift is faster and shadows are easier to cast. Treat cloud accounts, subscriptions, projects, and resource groups as first-class assets with owners, budgets, and guardrails. Discover services via provider APIs. Ingest tags from infrastructure as code, and record ephemeral instances as events attached to parent services so the historical picture remains coherent. To avoid shadow information technology, pair technical controls, account vending with enforced guardrails and cost visibility, with social controls, clear intake routes and prompt support, so teams have no reason to go rogue. When people can get what they need quickly and safely, untracked estates shrink. Mobility and bring your own device, spelled BYOD on first mention, introduce risk at human scale, so enrollment and enforcement must be clean and respectful. Devices joined through a managed pathway that checks basic posture, applies encryption and screen lock policies, and binds inventory to a directory identity. Corporate data lives in managed containers where possible. Remote wipe can target the managed portion without erasing personal content. And loss procedures are clear so people report quickly without fear. The inventory ties the serial to the person to the roles, and the roles to the data they can reach. That chain supports both daily work and fast containment. Lost or stolen assets demand immediate, rehearsed steps that trade hesitation for containment. The moment an item is reported missing, the directory record is evaluated for privilege, tokens are revoked, remote lock or wipe is issued if available, and monitoring searches for any subsequent network or account activity. Notifications are sent to the owner's manager, security operations, and facilities or law enforcement as policy requires, and a brief incident record captures times, actions, and serials so insurance and post-incident reviews are painless. The point is not drama, it is precision under mild stress. Retirement and destruction are as important as deployment because old hardware and data leak in quiet ways. A decommission plan removes the asset from service, backs up or migrates necessary data, wipes securely using approved methods, and records the wipe with a certificate tied to the serial number. Physical media destined for destruction follows a chain of custody with signatures at each handoff. And third-party destruction produces certificates that name dates, quantities, and methods. The CMDB entry closes only after these records are present, so inventory accuracy does not outpace reality. Clean exits prevent surprise returns. Metrics keep the inventory honest by turning hopes into numbers that change behavior. Inventory accuracy, measured by comparing discovery sources to recorded assets, tells you whether the map matches the territory. Orphan rates show how many assets lack owners or current tags, a red flag for both security and continuity. Unsupported versions trending shows whether technical debt is shrinking or growing and which teams need help. Add a measure for time to ownership on newly discovered assets, and one for mean time to retire after a decommission decision. When a metric crosses a threshold, it should open tasks, not just dashboards. Consider a scenario where an audit finds that 10% of production servers lack named owners and 5% run unsupported operating systems. The immediate fix begins with enhanced discovery. Ingest hypervisor inventories and cloud lists daily, reconcile against the CMDB, and flag any record without an owner as high priority. A small Tiger team meets with platform and application leads to assign owners within 48 hours, documenting decisions in the asset records. In parallel, unsupported systems are grouped by application, maintenance windows are negotiated, and upgrade or isolation plans are approved with dates. 30 days later, the follow-up shows owners on all records, unsupported systems reduced by 2/3, and remaining items with scheduled dates and risk notes. The failed finding becomes a case study in closing gaps quickly and transparently. To close, commit to a 30-day plan that raises inventory accuracy and retires risk you can name. In Week 1, enable or tighten automatic discovery across networks, cloud, and endpoints. Reconcile to your CMDB and assign owners to every orphaned record with a dated attestation. In Week 2, complete a tagging and classification sweep on production-critical assets, correcting values that drive patching, monitoring, and retention. In Week 3, schedule and execute upgrades or isolations for the highest-risk unsupported versions you identified. In Week 4, retire or decommission at least 3 risky assets, preferably systems with no business owner, stale data stores past retention, or shadow cloud projects, closing each with certificates or logged evidence. When you can name what exists, who owns it, and where it is in its life, the rest of your security program finally has solid ground to stand on. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.